Hello everyone, welcome to CH for us. Today we will be learning significant figures. So first of all, what is this significant figures? Significant figures are used to establish the numbers which is presented in the form of digits. So to know the number of significant figures present in a value, we have to follow 6 rules. So what are those 6 rules? First rule states that all non-zero digits are significant figures. 1 to 9, they are called as non-zero digits, and all these digits are significant figures. For example, if we'll take 2, 4, 8, 9, 5, so if we'll take 7, 6, 8, 4, 3, 1. In this we have 5 significant numbers 2, 4, 8, 9, 5. In this we have 6 significant figures. So any non-zero digit is considered as a significant figure. Now the second rule states that all zeros between two non-zero digits are considered as significant figures. So if we'll take 2005. So these two zeros present between two non-zero digits are considered as significant figures. So the total number of significant figures in 2005 is 4. Now the third rule states that all zeros to the right of a decimal point, and to the left of a non-zero digit. Let us take 585 here. So the zeros which are present to the right of a decimal point and to the left of a non-zero digit, they are never significant figures. So these are not significant figures at all. So the number of significant figures in the given value is 3, 5, 8, 5. These are the significant figures. Now fourth rule says that all zeros to the right of a decimal point are significant only if a non-zero digit does not follow them. So again, this is a decimal point and we take zeros to the right of a decimal point, and it should not be followed by any non-zero digit, which means we should take 20 here. If we take 20.00, the number of significant figures here is 4, because the zeros which follow, which will be to the right of a decimal point and which are not followed by any non-zero digit, they are considered as significant figures. Now all zeros to the right of a last non-zero digit are significant figures. For example, if we'll take 0.004850, so these zeros are not significant because all zeros to the right of a decimal point and to the left of a non-zero digit are never significant figures. And what about these zeros? These zeros are to the right of a last non-zero digit after the decimal point. Okay, after the decimal point, they are significant figures. So the number of significant figures in this value is 5, 48500. These are the 5 significant figures in this value. Now the last rule states that all zeros to the right of a last non-zero digit are significant if they come from a measurement. See, if we'll take 10850, so the number of significant figures in this value is 4. Only 1085 is considered as a significant figure. But in 108,500 meters, even these two zeros are considered as significant figures, and the total number of significant figures is 6. Right? Because this value is a measured value. Hence, all the zeros to the right of a last non-zero digit are significant if they come from a measurement. So these are the 6 rules we have to follow to find the number of significant figures in a given value. Now we will be learning how to round off a given value. Rounding off. So for doing this, we have to follow 4 rules. The first rule is, if we'll take 4.853. So 3 here is the last digit and 5 is the last before digit. So if the last digit is less than 5, then the last before digit is left unchanged. how do we do this? See, we have to round off 4.853. How do we round it off? See, 3 is less than 5, so the last before digit should be left unchanged, 4.85. The number of significant figures here is 4. Now to the right side it became 3. So this is how you will be rounding off a given value. Now the second rule is, if the last digit is greater than 5, then we have to add plus 1 to the last before digit. We'll see an example. 4.856. 6 is greater than 5. So what we have to do? We have to add plus 1 to the last before digit, which is 5. So 4.86. This is how we will be rounding off a given value. In this we have 4 significant figures. To the right side it became 3. 3 significant figures here. So this is the second rule. The third rule is, what if the last digit is equal to 5? Then we have two ways. We have to check if the last before digit is an even number or if it is an odd number. If it is an even number, we have to leave it as it is. It is left unchanged. If we'll take an example here, it is say 4.825. Right. So the last digit is 5 and the before digit is an even number. So when we round it off, we will be getting 4.82. The number of significant figures here is 4. Here it became 3. Now again you can round it off. See, 4.82, right? This one. So 2 is less than 5. So what if it is less than 5? We have to leave the before digit left unchanged. So 4.8. 2 or 3 significant figures became 2 significant figures. So this is how you will be doing rounding off. Now, what if the last before digit is an odd number? If it is an odd number, we have to add plus 1 to that odd number. We'll see an example. 3.835. 5. The last digit is 5, equal to 5. The before digit is an odd number. We have to add plus 1 to this 3. 3.84. So this is how we will be doing rounding off. Now we will see an example. Okay. 4.72 plus 5.63 plus 33.21. We have to find out the number of significant figures in this problem. So how do we do that? First we have to write the number of significant figures in each of the value. Here we have 3 significant figures, 3 significant figures, 4 significant figures. Then what we have to do? We have to add them up. 4.72, 5.63, 33.21, 5, 6, 15, 13, 43.56. Right. So 43.56. The number of significant figures here is 4. But this is the wrong answer. Why? Always the number of significant figures in the result should be least. In the result, we should always get least number of significant figures. What does that mean? In the problem, we have to check which value has least number of significant figures. So 4.72 and 5.63 has least number of significant figures. So our result should also contain only 3 significant figures. What we should do then? We have to round off the given value. How do we do that? We have to check the last digit is greater than 5 or less than 5 or it is equal to 5. Here it is greater than 5. What if it is greater than 5? We have to add plus 1 to the before digit, which is 5, 43.6. So the number of significant figures here is 3. So this is the correct answer. Okay. Now what if it is, this is the same method we have to apply for the subtraction. What if it is multiplication or division? So what if it is multiplication or division? We'll see how to do it in a multiplication problem. Okay. 5.2 into 10.3 into 6.732 into 10 power 3. So now again they will be asking find out the number of significant figures. So how do we do that? First we have to write the number of significant figures in 5.2 and 6.732. Here we have two significant figures. Here we have four significant figures. So first we have to multiply 5.2 into 6.732. So how much that would be? 5, 6, 30. Okay. It is 35.0064. So this has how many number of significant figures? 1, 2, 3, 4, 5, 6. 6 significant figures. Okay. Now 10 power 3 into 10 power 3 is 10 power 6. So 35.0064 into 10 power 6 is the answer. So what we have to do, first we have to round off this 35.0064. How do we do that? First we have to check the last digit is greater than 5, less than 5, or is it equal to 5. It is less than 5. So the last before digit should be left unchanged. 35.006. We have to get it to the least number of significant figures, which is 2. Okay, so here we have again 5 significant figures. Now again 6 is greater than 5. We have to add plus 1 to the before digit. Again 1 is less than 5. The last before digit should be again left unchanged. Okay, so 35.0 into 10 power 6. So what will be the answer? 35. Right. So this is our final answer, and the number of significant figures here is only 2. 2 significant figures. Why? Because the zeros, if they are to the right of a last non-zero digit, they are significant if they come from a measurement. So we did not write any meters or kilometers, whatever it is, we did not write. So these all are not significant figures. Only 35 is a significant figure. So 2 significant figures. We have to always get the least number of significant figures in a result. So this is how you will be calculating the number of significant figures, and how you will be rounding off a given values is this way. Okay, so that's it for today's video. Thank you guys.